region's helping to transform physics research worldwide by playing a key part in something called the TeraGrid. It's a network of computing facilities, including the Pittsburgh Supercomputing Center, that offers scientists computing power that would have been barely imaginable just a few years ago. Ralph Roskies is one of our region's innovators, the co-scientific director of the Pittsburgh Supercomputing Center, and back with us. Good to see you again.
I'm glad to be here. Thank you.
Yeah, it caught my eye a couple of weeks ago. Saw you'd made a presentation to the Physics Society or Association about some of the work that's been enabled by what's been happening here. I guess, why don't we start first with what the heck the TeraGrid is?
So the TerraGrid is really a consortium of large-scale, let's call them supercomputers throughout the country, which have been funded by the National Science Foundation. So it is the infrastructure by which scientists really get their large-scale computations done these days.
Okay.
And we're linked both administratively, so to speak, with joint efforts of the people involved, but also we have high-speed computer networks between the different sites, so we can transfer information from one place to another place. So you can do part of your calculation in Pittsburgh, and you can do another part of your calculation in Illinois, and another part in San Diego, and so on. And this is actually very important because we say supercomputers, but they're really very different, and they each have different kinds of capabilities. And a scientific problem often needs many of those capabilities. So you need to do part of the problem here and part of the problem there, and putting it all together. And we're trying to remove the barriers that people would normally have of learning what happens in Pittsburgh and then having to start all over again and learn what happens in San Diego and what happens in Texas and learn each of these systems on their own. So we're trying to make it look as though it really is one system. In order to make it easier for people to use.
So for the physicists, it's the one-stop shop of
That's right. It's the one-stop shop, right.
Okay, and so what are the implications if you can really marshal then all the resources of all these incredibly powerful computers? What can you do that you couldn't otherwise get done?
There are some parts of physics which are just not conceivable without the power of supercomputing. And one of them is cosmology, how the cosmos evolved. And another one is so that's the very, very large. And then there is the very, very small, the sort of subatomic elementary particle physics. So in both cases, you need very powerful computers in order to calculate the implications of what you think the appropriate equations are. But there's no more paper and pencil, or even very rough hand-waving arguments are very difficult to make here, so you really need these very powerful computers. So our advances both in cosmology and in elementary particle physics have gone hand in hand with the development of supercomputers.
Unbelievable. And that's something, I mean, here in Pittsburgh, what? The Supercomputing Center is almost 25 years old, right?
Right, 23 years.
Yeah, I imagine the computer you have out there in Monroeville now is a little more powerful than the one you had back then?
It is indeed more powerful, and the cost effectiveness of computing has just been staggering over those 23 years. I mean, I tell people it's at least a factor of 10,000. So if you think about cars, and you would have bought a car for $30,000 back in 1986 when we started, that equivalent car would cost you under $3 today. So if you think about that, you realize you would use that car in a totally different way from the way you normally use cars. And so computers are also being used in entirely different ways now.
Unbelievable. That's what I want you to get your computer working on, is how to deliver that $3 car.
How to deliver that $3 car. You wouldn't even bother parking it. It's too expensive to park.
Throw it away,
just junk
right?
it,
Yeah,
right?
you dent it, you get rid of it, get a new one.
Right.
So what does it really have meant to our region? I mean, it's wonderful to be on the frontier of science and enabling all these breakthroughs to happen. I mean, is there a more down-to-earth sort of economic impact of what's going on here?
Sure. I mean, just from the point of view of raw economics, so to speak, we've brought in terms of federal funding, well over $400 million to this region from the grants that we've been able to get over these 23 years. So that part of it is relevant. Also, from the point of view of the state as a whole, we looked recently, and the state people who use our computer bring in $30 million a year in research grants. So that's another contribution. And besides that, we do a lot of work in workforce development. So we hire 25 to 30 undergraduates every year, and they work with us, and some of them turn out to be really good, and we actually end up hiring some of them after they graduate. And we've been working very hard to do K through 12 programs to get ideas of how people use computation in science into the K through 12 curriculum.
Wow, talk about having an important long-term impact on science and society.
And then we also work very much with corporations, companies in this region. So we've recently done interesting work with PPG, we've done work with MedRad, we've done work with Westinghouse, we had previously done work with Alcoa, all these things. So that also contributes to the economic development here.
Wow, really exciting. Great to hear we're still out there on the cutting edge and a component of the TeraGrid. Ralph Roskies from the Pittsburgh Supercomputing Center. Thanks so much.
Thank you very much. Pleasure.
And we'll be back in a minute with more of our region's business. Stay with us.